Hello everyone, welcome back to this Siemens brief motion control series video. By using the analog output for DC motor and encoder feedback, and I'm using the Siemens small controller S7-1200, this small controller. And in this test, we do not need any other technology, hardware, or module. We just use this S7-1200 CPU, and it has a built-in HSC high pulse counter. And we are using the analog output to control the DC motor. So in the previous video, I used around 10 to 20 minutes explained how this hardware looks like and how we quickly build up this access, this hardware configuration. And I'm using this analog QW100, this one channel 0 to 10 volts, the analog, and this analog signal go to the PWM and that driver board. And the driver board connect to the DC motor. And then to measure the speed and the precision, I'm using the incremental encoder, very simple incremental encoder. And I'm using A and B, two channels connect to two digital inputs. That two channels go to the inputs of the PLC. And to read the encoder value, I'm using the HSC1. And I set the encoder as A and B counter, and I'm using input 0.1 and 0.0, A and B, two channels. And I can read the speed and the precision. Also, I briefly showed how can we tune the gain parameter. That time, the initial, we start from 10 and increase to 40 and then go back to 38 or 36. So basically, we briefly and quickly set up this closed loop positioning control. And if you have this controller at home or in your shop, and you can quickly build up this controller and this DC motor system, or maybe you have the VFD in hand and you can use the same idea, analog output connect to the VFD and use the inductor motor and use the encoder read the inductor motor positioning feedback after the gearbox or after the shaft, right? So you can quickly, briefly build up this positioning control very quick. And after we use this access, build up this configuration, and after we use this control panel to jog and positioning control, relative or absolute control this motor, we verify if the motor can travel correct direction and the correct position as well as the velocity. Then we can use MC function blocks to enable home and jog as well as the velocity control or positioning control. So we will use the program. And in this video, I will briefly show how can we do that. Actually, I used one video before, shows the detail how can we set up the function block. I explained very detailedly. In this playlist, I have almost 40 videos. It includes Siemens motion control, Allen Bradley motion control, and the Trinket back-off motion control. If you are the new learner, try to set up the rough idea how can we use the Siemens small controller to set up the motion control closed loop. This video pretty fit for you because I will briefly introduce how can we do that. I will step by step, hands-on. Alright, let's step by step. So go back to our project. Let's go offline first. And let me firstly set up one FC. We can quickly set up this. Name DC motor control. Okay. This is the FC. Okay, we set up this FC, and don't forget from the OB1 we call this FC. Okay, our main function blocks, MC function blocks, will be called at this corner technical, and drop down list this motion control. All those function blocks will be called within this FC. Before we start to program MC function blocks, let's create a DB. And inside the date block, it includes all the tags we will use. So we can add a new block and click this date block. We can name that DB underscore DC motor 1. Okay. Probably we have multiple motors, so we start from 1. And number, we can also start from 10. This is the DB, so they can use the same number. FC is FC, DB is DB. And inside this DB, we can create multiple variables. Okay, so at here, I can declare the variable name. Let's prepare the tag and the variable names at first. Firstly, I will name that execute MC reset, and then execute MC power. And those are the commands to trigger the function blocks. Okay, and then let's put the set point data. For example, what the velocity value, what the positioning value, right? We can name that set point velocity. And keep in mind, for the 1200 controller, the real value is using the rail. For the 1500, it's using the long rail, so we need to type in the L rail. So for the 1200, it's using rail. Okay, set point velocity, and here let's set set point distance relative. Okay, and set point distance absolute. Then we need some status. So for example, status of standstill. That is the bool signal. This represents to check if the motor at standstill status without any moving, right? And then we can declare the MC error. So this is a summary to show if this axis has an error. Okay, and then two key value. One is the actual velocity. One is the actual position, actual velocity, and actual position. So keep in mind, this velocity, we name that rail value. And again, for 1500, that's the long rail. Okay, and this status MC error. So the bool, once it's on, that means axis has an error. This is very key and core variables. Actually, in the actual case, you probably need to declare more than this, but those are the essential variables. That's enough for us to do a quick or simple test. Okay, so after we declare this, we can flow this, drop it into this corner. Okay, and then go back to the MC10 from the network here. So let's start from the second network. Right click this, add new network. And let's firstly declare the error summary. Okay, this is very important because every trigger, especially for the power on for the motor, we need to guarantee there's no any error in the system so we can power up the motor, right? So the result will be this from our DB, this status MC error. So I can drag this tag to here. This is the beauty of the TI portal. So we can drag and drop. And we need to grab some important value. For example, so the axis is this, DB1, right? So let me firstly drag this axis here. And then we press the dot. So it can show the variables within this axis value, this structure. So we need to grab some important status. For example, this arrow bits and this following arrow, and some status from the axis. So for example, let me pick the arrow bit. So within this arrow bit, it has communication fault, configuration fault, drive fault, following arrow, and sensor fault, and drive fault, right? So for example, I need to pick the system fault and do the parallel logic. So system fault, drive fault, and sensor fault. Those are very important. You can also pick others associated with your system replication, but those are the essential. So one of them turn on, that means the system has an error. And then next one, we can call that MC reset. We can drag the MC reset function block from the right side motion control, MC reset. This I can start from the 101. So MC reset DB for axis 1. So I can add this _1. Let's create this a single instant. So this video is especially for the new learner. So I won't create like a multiple instant. So I try to set up like a very regular way. Okay, so that named 101, the MC reset. So it automatically creates this DB101. And where is this background DB101? They locate under the system block under here. We do not need to change or organize that. Basically, let the system automatically organize its system blocks. You automatically create that. And then we can drag the bool signal for execute this MC reset. Okay. Second, okay, find out the DB, this variable we create, and drag to here, reset. Okay. And this access is very important. That allows the system or program know, so when we trigger this MC reset, which motor or which access it should reset the fault for that, right? So our target is this. How to connect them? Very simple. Also drag and drop. Drag this DB1, drop to here, release. And that's it. So this will allow this MC_reset know, okay, it's operating this DB1, this access, DC motor access. Okay, this is MC reset. The next one, that's MC power. We will use this function block to power up this access. Okay, so power up, we will use the MC power, drag to here, and same thing. So we will start from 102 and add a _1. Okay, and same thing, the access, we will operate this access, drag to here. Okay, and enable is very important. We will use this enable, the power, this command. And other than this command, we also need to consider if the system has an error, right? So we can copy this, and we need a system without error. So we need this negative logic without an error. And once you turn on this power, it will turn on. All right. So next, this is the MC home. So we can direct set the value for the access using this function block. Let's drag the MC home. Same thing, we will use 103. Okay, and drag this access and execute. We will use MC home execute. Okay, and this value allows us to directly set the value we set here. Usually by default, we will set the 0 value when we execute the home, or we will run the automatic go home. So basically by default, very simple function, once we trigger this function block, we set a 0, this value setting to the access. For this purpose, we will set default value 0 mode on this MC home. If you want to check out the MC home is a little bit complex topic. So if you want to read the detail, you can click the F1 to find out the help for this MC home. Okay, we can see mode 0, that allows us to directly homing the absolute, the homing the access. So especially for here, mode 0, we directly home the access, set the value directly to the access. Okay, this is MC home. Next one, also important, that's the jog. That allows us to manually control the access. We can jog forward or jog backward. Manually move the access, manually move the DC motor, right? So we can drag the jog, move jog. Okay, we can drag this access here. Forward, reverse, they are individual to bool. And here, that's the velocity. If you recall from the last video, we used the 1 revolution per second. So that speed, we need to run 360 degrees. So the velocity per second, that is 360. That every second per second, we run 1 revolution, right? So that's why we set a 360 here. We can also use another variable, that's the real value. So if you leave the mouse here, it will show you which kind of data type. The real, the word, we can type in here, we can input here. Okay, this is MC jog. And then we can drag the three main motion control command: velocity, relative move, or absolute move. So move velocity. And we can use the number 105. Okay. All right. The axis, same thing. Drag this axis and drag the execute move velocity. And which kind of speed we will run? Let's run a little bit faster. For example, 720. And that's it. This is a speed setting here. And once we trigger this, the axis will start to move. But how we can stop the axis? So this move velocity that's used to trigger the axis to start to move a certain speed you set here. But how can we stop the axis? We will use the stop command, or we call the Halt command. So we need to drag this MC Halt. So Halt 106. Keep in mind those numbers cannot be overlap. So MC Halt is very simple. Once we trigger this, the axis will try to stop. So we need a trigger signal, MC Halt. Okay, and then the two common function blocks. Usually for the automatic axis control, we will use MC relative or the MC move absolute. Okay, let's firstly program this move relative. Every time we trigger, this axis will travel the certain distance. Okay, and then score 1. Okay, this is MC move relative. Okay, same thing, the axis and the trigger move relative. And distance we can set here, so we create this side point distance relative and the side point distance absolute. We can drag this real data type to here. And this velocity, we can set this velocity here. Okay, this is the velocity setting. And then let's drag the MC absolute. Okay, this time we name 108. Move absolute dB underscore 1. Okay, same idea, drag this axis first and trigger from the bool move absolute. And for the position, that target position, so we will use the side point distance absolute. Okay, and the velocity, we will use the same input. So we can use a different variable just for simple demonstration. So we will use the same. Here, that's the MC underscore move, MC underscore move absolute. Okay, and then eventually we will grab three important variable status. So firstly, that is a standstill. The standstill will grab one variable from the axis and transfer that's a status standstill. Okay, where this standstill comes from? That comes from our axis. So same thing, drag this axis here and press the dot. So we need to find out status bits. So within this bits, there's one signal named standstill. Okay, standstill here. Okay, this is standstill. Then we will read the actual velocity and the actual position from this axis. So we will use the move, the instruction. Okay, find out the basic instructions. Find out the move operation, move. So let's drag this axis here and same thing, press dot. Let's find out actual velocity. Find out the actual velocity. Okay, actual velocity. Copy this, the actual velocity from the axis to our dB. So our dB here. And same thing, we can copy the second move. And this target, this time, that target is the actual position. So we drag the axis again, press dot, the actual position. So we can read the actual position from the axis. So same thing, put the velocity and the position here. And this is a standstill. You will ask, why not every time I put comments here? Because you will see how beauty of this once you close this all networks. So from this shrink wheel, you can quickly know for every network what it's doing. So for the troubleshoot, you can quickly direct the problem where it's located, right? For example, if you try to find this move velocity, you can quickly find out where it is. If without those comments, every network will show like this. So if you have a 20 network, you don't know which network is doing what. You can also click this open all network. We can look at the details at here. All right, so we quickly build up those function blocks, and keep in mind all those function blocks located within this MC10. And then from this op10, we call this FC10 here. Okay, so then we can download our program. All right, so we download, and then we can click this online. Okay, so once we see all show screen, that means offline, online, they match. And then for the commissioning, we can open the MC10. And then we can click this online, monitor all. And firstly, we can trigger the MC reset to reset all the fault. Okay. And then we can power on the motor. So now without any error, now we can power on. Keep in mind, we need to leave enable on this MC power. So without any error, now we power up. Also, to check out the current position and velocity, we can also use the watch table. Okay, let's add one watch table. Okay, this watch table allows us to monitor the variables. And then we can open the DB10. This will create all the variables, right? And we can drag the actual velocity and the actual position to here. Drag them to here. And click this monitor. Okay, we can monitor the current position and the current velocity. And now, since I tested in the previous video the value, so now we can home this axis. So to home this axis, we can execute this execution command. We set 0 directly to this axis actual position. Now I can trigger. See, once I trigger this on, it can set this 0 setting to this axis. Now we home the axis, and we can manually forward or backward this motor. So let me try the forward. This is basically will be used as the manual mode. We use 2 buttons on the HMI or very simple function. So we can trigger. It will forward the motor with a slow speed. Basically, this slow speed will be set here with a slow setting. Okay. Now we can turn it on. We can see the motor is running. Okay. And the setting that's a 360. So the setting here, we can see the actual velocity. Since this DC motor, that my PWM module, that's not quite linearized, so it will show the velocity vibrating here, but you can imagine, so the speed roughly around 360. After all, this is very simple and poor, this test system, but it's very useful to demonstrate how that works, this hardware system, right? And this actual position is running. Okay. Also, we can verify the direction and if the encoder is working properly now. If I release this button, that basically release the command, so the motor will stop. This is the jog function. Okay, let's home that again. Now I'm going to test the velocity. So let's trigger this home execute. Okay, we'll home this access again. And now I will use the MC move velocity. Okay, so my setting, that's the 720 degree per second. So that means every second it will run 2 revolutions. So I will trigger that, the motor will start to run. As I can see, it will keep traveling. If I turn this off, we can see the motor will keep running because this is the move velocity. The only way we can stop the axis, stop the motor, we need to execute this MC Halt to stop the axis. Okay, now I can stop the axis. Before that, we can see this is speed and this is the position. The motor is running. And now I can halt the motor. So once I trigger, boom, it stopped. Velocity 0 and stop there. Okay, this is MC Halt. And then let me demonstrate the move relative. And before that, let me zero the axis so we can see the value there. And now let's go to the home. So let me trigger this. And to operate this easier, we can drag this execute command to here. We can also monitor that. And before that, I can also insert a raw here. And so we know this is the position we are monitoring. And this is the command we can trigger. Okay, so if I trigger this, I can right click here, modify to 1. So click this icon. So we set 1. Then we will see actual position equal to 0. Don't forget, reset that to 0. Okay, transfer the value, modify. All right, this is the monitor, this is the modify. And now we can test that move relative. And firstly, let me set this distance target. For example, I can set target 1000 degree. Or let's set 3 circles. 3 circles, that is a 1080. 3 times 360, right? Okay, we will see the motor will run 3 revolutions. And the velocity, let's run a slow speed, 360. This is 360 degree per second, okay? And then we can trigger this command. Meantime, we can monitor the motor if it runs 3 revolutions. Okay, it arrived this 1073, and our target is 1080, and its offset is 3 degrees. So as I introduced, I haven't fully optimized this axis. Also, since this is analog output, we are using the PLC controller as the positioning closed loop. It doesn't have a current loop within the drive board. Usually if we are using the VFD itself is also have a closed loop inside. So in this case, we are using very simple structure. So I won't too worry about this positioning offside. The key point for this video, we will show how this function block run. And for the move relative, once I trigger this move relative again, it will keep going. Every time I trigger, it will travel 1080 degree. So for example, now if I trigger it again, it will travel 3 revolutions and to the next position. Every time it trigger, it keep going like this. Okay. This is the move relative. Now let me reset this axis. Okay, and now let's demonstrate this move absolute. Also, we can see this standstill. Now the motor is at the stop status, so the standstill turn on. Once the motor start to move, and while it's moving, the standstill will go off. This allows to know what the status of the motor. Okay, now for the move absolute, this command, let's set. So this target, let's target to 1080, 3 revolutions. But this time, this is the absolute position. So once it's traveled to there, if you trigger again, especially if the motor has been at this position, it won't travel anymore because this is the absolute position target. Okay, now I home this axis, which is 0. So now let me travel. Trigger. Before it reach there, if we release, it still keep going because this command is only trigger command. Okay, so it travel to 1070. Okay, if I trigger this command again, the motor won't move because in the system, it know it has been arrived the 1080 around there, so it won't travel anymore by using this move absolute. Okay, this is the absolute position. Unless we change to 3000, so it will travel target to 3000. For example, now if I trigger this command, move absolute. Okay, this is the axis target. It's try to travel to 3000. Once it's arrived there, that's it. So this is a move absolute. Okay, and let me target to 5000, and this time let's watch the standstill status. Okay, if I zero this axis, okay, now 0. Let's travel to 3000 and let me trigger. So we can see while the motor is moving, standstill go off, and once it's reached the target or around there, standstill on. That means motor stop there without any moving. This is standstill. And in the meantime, we use the actual velocity, store the actual velocity and the actual position from the system, so we can read the actual velocity and the actual position. This is the two common status or value we need to monitor from the axis. Alright, that's it for today. So this is a very brief and simple operation or programming to show how can we use the MC function blocks to control this DC motor closed loop system. So we use two videos to show how can we quickly set up this. Basically, if yourself, you could use 1 hour set up everything and test these things. So it's very simple, and I hope these two videos can help you to set up the basic idea how can we use the Siemens 1200. This is simple and cost-effective controller, set up this closed loop and motion control system. And also keep in mind, since we are using the access control, once your motor system, drive system, or encoder system got changed, the behind the program and the configuration won't be changed too much. So you can imagine if you change from the VFD to servo motor, the only need to change is this area, right? And the encoder, probably you can read the encoder from the perfect night or some other encoders. So the only changed portion, that is this area and the drive area. Other area won't be changed, especially for the program. The program only need to identify which axis is operating. So if you change the hardware within this axis, the program doesn't care, which means once you build up your own template, those motion control template, you can use for multiple projects. Alright, that is for this video. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.